Hello everybody, I am Mr. Salt, and today I am doing a little video on Mr. Pettybone's Earth Science Marking Period 4, Week 4 Topographic Profiles assignment. This assignment is looks like it's pretty long, pretty in-depth, and it might be intimidating for some, so I thought I might do up a little video demonstrating some of the techniques here. When you open your assignment, you should get a PDF that hopefully opens in Cami that allows you to do some annotations in here. Cami, unfortunately, I cannot find where Cami would have a ruler, which is kind of one of the things that's really useful to have in here. So I'm going to use a ruler tool myself. I'm using an annotator tool to show you how to do this, but I think you can do it without a ruler. It's handier to have one. All right. So here we have, base your answer to the question on the topographic map below and on your knowledge of Earth science. Point A represents a location on the Earth's surface. Where's point A? Point A, point A. Oh yeah, right there. Lines B, C, and X, Y are reference lines on the map. There's X and Y, and there is B and C. Points D, E, F, and G represent locations along Coe Creek. Elevations are shown in feet. Okay, so we know that our contour lines are shown. That our measurements are shown in feet, or elevations are shown in feet. So if I see a 300 here on this line, that tells me this line is at an elevation of 300 feet. I see a 200 here. That means I have an elevation of 200. All right, let's see what the problem. So I have this graphic and this legend here. What's the question? I have to scroll all the way down here to figure out what the legend. What am I actually doing here? Right? On the grid below, construct a topographic profile. Okay, that's what we're doing. We're doing a topographic profile of the land surface along the line from point B to point C. All right, let me go look at what I'm doing here. Okay, I'm going to do a profile from this point here, B, to C. I'm going to do a profile of this space here. Plot the elevation of each contour line that crosses line BC. Connect all 9 plots with a line to complete the profile. Okay. So we're going to do a profile. So I'm going to start with a drawing tool here, and I'm going to do green. I like green right now. I'm going to start with B, and I'm going to go to C. Let's see. Do I know where any of these things start? Well, I noticed that C is this dark line here, and if I follow that dark line, I see that this dark line represents an elevation of 200 feet. So let me mark that right now. 200 feet. That's where that's where C is. B, where is B? Well, B is, it's marked too. B is marked at 340, so 340 feet. Okay. Now what do I do? Well, I've got these different contour lines here. I'm going to have to figure out what each one of these contour lines are. I'm going to start with what's easier for me right now. What's easier for me right now is I see this dark line, and if I trace this up, I notice that that one's going to be also labeled at 300. So this dark line here is 300 feet. Okay, and then now what do? I am noticing that this goes from 300 to 200. So that means this is at a high elevation, this is at a lower elevation. I'm going down from 300 to 200. And now I need to figure out what is the interval here, right? How much am I going down for each line? Well, I have to look at the legend for that. I'm noticing one thing here. It says like this, looks like this distance right here is equal to 3 miles on the map. The contour interval, that's very important. That's what I want to know right now. The contour interval is 20 feet. That means the elevation differences between each one of these lines is 20 feet. So if I start at 300 and I'm going down, and if each one of these lines represents 20 feet, then this line here is going to be 300 minus 20. I've gone down 20, so that's going to be 280 feet. And then this one here is going to be 260. I'm going to go down another 20 feet. And then this one here is going to be 240 feet. And lastly, this one here is going to be 220 feet. All right, great. I've got all these contour lines kind of plotted. I know the elevation of each one of these. And now I've got 300 to 340. 300, 340. Well, I know I'm going up. The problem is if I do this as 320, and this becomes 340, well, then what's going on here? Well, what's going on is this space, this particular, I'm noticing that the lines change. This is not an ordinary line here. I've got all these little hash marks going on the inside of this circle. So let me see what that, let me go to the legend and see what that means. It says key. The key says, oh, if you see a line like that, that is a depression contour line, a depression contour line. So what's happening here is there must be some big hole in the ground. Geez, that hole in the ground is, if I'm going down, if this is 340, then that would be 320. That would be 300. This thing goes down 60 feet, or I'm sorry, 40 feet, right? 320, 300. It's a 40-foot hole in the ground. Now, it's actually a depression, not necessarily a hole, because look at the distances. This is like 1 mile. So this is a drop of 40 feet over the course of 1 mile. You'd barely notice that if you were walking it. It would just be a slight downhill, but it is a depression that we need to be aware of. Okay, so now I think I have everything I need. Oh, I have to resolve what's going on here. Well, what's going on here is this is 340, right? And then this is going to be 320. And why do I say that? Well, this line here is a depression line, which means that it's trying to tell me that there's a change in direction. There's an unusual depression going on here. So these are both at elevation, so it's basically flat between these 2 points. All of this between here and here, all this is all flat, and right at this line, it starts going down. Right at the depression line, this is when it starts going down. Okay, so 340, 340, 320. Great. So let me go back down. Let me go back to my graph, and I can begin looking at this. So let's see. B. What elevation does B start at? I can just quick reference this. Oh, yes. B starts at, I think, 340. So let me mark that down on Cami there. 340. Where is C now? Where is location C? Let me go back to my map. Okay, C is 200 feet. 200 feet. Okay, that would be right here. And now the trick between here and there is it's tricky, because normally what we do is I would take a piece of paper and I would take that measured piece of paper and I would make a little mark. So I would normally be taking a wish I could do that. I kind of can do that, right? I would take a piece of paper. Let's pretend this is a piece of paper. All right. Can I do that? No. Let me do a rectangle. And can I change the? Is it possible for me to rotate this rectangle after I've got it? I don't know. I don't deal with Cami too much, so I don't know what's possible here. I'm just playing around. Apparently, no. Apparently, rectangles do not like to be rotated in Cami. Well, okay. So let me say I have the edge. I take this line, which I take out a piece of paper, and then what I would do is I would take my pen on that line and I would mark where the contour lines cross. I would mark there, and there, and there, and there. All right, I'm just, whenever my line crosses, I would mark that, and then I would go and I want to select all of you. I want to select that line, and I also want to select all of these little dots. And I would take this with the little hash marks on it, which Cami's not going to let me do. Okay, maybe it will. I would take this little mark and I got to pull it all the way down. So this is going to take a couple different steps doing it with Cami. And it won't let me take it to a different page. That's unfortunate. I really wish it would let me do it to a different page. That would really be important here. And I would take this line and I would put it straight up here, and then each of those hash marks becomes with these intervals. Because I don't have that, I'm going to use a tool that you don't have, which is unfortunate. You don't have this kind of tool in Cami. I'm going to use a ruler tool. All right, so that's the tool I'm going to use. And I need to open it up. I'm just going to have to remember some things here. I'm going to put this 0 of my centimeters on point B. I'm going to rotate my ruler over to point C. Let me get this better. And now I'm going to have to remember some things here. I'm going to need to remember the first hash mark needs to be at 1.5, the next one at 1.8, and the next one at 2.3. All right, 1.5, 1.8, 2.3. All right, get rid of my ruler. Bring back my ruler. All right, I'm going to need to make a cami hash mark at 1.5 right there. Oop, I would need to make a mark right there, and then 1.8 right there, and then 2.3 right there. Yeah, and I would need to go back up, and then I would get my ruler back out, and then I would line this back up. And again, that's only if I was in the classroom, I'd be writing all these numbers down, all the little marks I'd need to make. I'd be writing them down. So 2.3, there's my 2.3. Now 3.2 and a half, 3.2, 4.2, 5.8. So 3.2, 4.2, 5.8. Boop. Let's see if I can do this. Oh no, the numbers are already fading from my head. This is sad. Right. What was it? Was it 3.2, 4.2, and 5.8? Was that what it was? I forget, honestly. Well, I hope that works. I hope that works. And then what do I have to do? Oh, I have to do some more rulering. Some more rulering. Putting this here. Measuring that. There was my 5.8, I think, right there. And then I need to remember 8 and 9. Oh, no, it's 8. 8. All right. Let me move this down. We're back. Ruler. Mark it up at 8. All right. I'm going to get rid of my ruler. And now I have to do this in Cami. I have to mark it up in Cami for this to work. All right, Cami, give me. Oh no, I need to do a drawing, don't I? Okay, there. Cami will let me do this eventually. Here, here. I'm just marking on top of what my annotator did. Technology is great in some ways. In other ways, it can make life harder. All right, and this is one of those instances where technology makes life harder. All right, Cami, let go of my. Oh, um, yeah. Okay, there we go. So now I have it in Cami. Woof! Wasn't that tough? Now that I have my markings where they are, I know I'm dropping, right? My first marking is going to be stay at 340. And then from there, I'm just going down by 20 feet each time, right? So right there, I'm going down that much. There, I'm going down another 20 feet. There, I'm going down another 20 feet. There, another 20, another 20, another 20, and then there. So let me break out my pen. This makes life easier. You don't have this. I'm sorry about that. There. That's kind of how we do it. All right, that's kind of how we get that done. Woof. All right. If you need this paused, you need to copy this, go ahead, pause me. That's the beauty of video. You can pause me anytime. You can slow me down. You can speed me up. You can fast forward. You can rewind. I'm moving on to the next problem. Figure 2. Base your answer to the question on the topographic map below and on your knowledge of Earth science. The map shows an area of New York State that includes a campsite, trail, and buildings near a lake. Points A, B, C, and D represent locations on the map. There's A, there's B, there's C, there's D. On the grid below, construct a topographic profile along BC. All right, we're going to do a topographic profile of this. Plot the elevation of each contour line that crosses BC. Connect all 7 plots with a line to complete the profile. Okay, so I need to start with just examining what's going on. Let me see if I can figure out where B is at. Oh, that's easy. Oh, okay. Actually, this is both easy, right? B. I'm not even going to bother. I'm just going to circle it. B starts at 550. C starts at 550. So in this contour map, if I go to the contour map, B is going to start at 550. C is going to end at 550. All right, let's see what happens after that. Oh, okay. Now, I am noticing that there is a woodland brook that goes through this area. And what do you know about water and contours? Well, hopefully you know that, water tends to flow down, right? Water flows downhill. Water goes downhill. So the fact that there's a creek in between B and B and C are the same elevation, that tells me that this woodland brook is probably the lowest elevation, and that what's happening here is I'm up high, and I'm going down till I get to the brook, and then I'm going up, and I'm going up, and I'm going up till I get to C. Right? I start at 550, I'm going down till I hit woodland brook, and then I'm going back up to 550. Another indication that I'm going down these contours is this 550 right here, which tells me that this, between 500 and 500, between 550 and 500, I must be going down. Now, I need to figure out what these contour lines represent. What does each one of these lines represent? I need to go to the legend or the key. All right, there's the key. That doesn't help me out right yet. This gives me the distance. Oh, wait a minute. Contour intervals, 10 meters, which means this would be 10 meters lower, 540, and that would be 10 meters lower yet, 530, and this would be 520, and that makes sense. This is 510. That looks like 5,100. Let me see if I can get my eraser out there and get rid of that extra zero I put in there for some reason. Okay. Which means this one here is 540. How did I know that? Because it's the same line as I had over there that I already marked. This line here is 530. All right, barely can see that, but it's there. This woodland brook is not a contour line. I'm going to leave it alone. I have a contour line here. Notice how this snakes around and becomes, well, that's 530 again. I'm coming back up. That would mean this is 540 because I'm coming back up. And this would mean this is 550. And this is flat, so this would be 550. And I can see that because it's the dark line. All right, so it looks like a 300. All right, I can begin to contour this. Now, to do this properly, again, I'm going to need like a piece of paper to measure these contour lines out. I hope, let me try if I can do, I'm going to use a line to measure. I'm going to use a line to measure between here and here. That's how I'm going to do it this time. All right, now let me select the line I use to measure. Let me bring it down here. I have found a Cami solution. It's not the best Cami solution, but it's a Cami solution. This is how we can do it. Right, I can make a mark right here right now, and then I'll take that line back up here, and I'll make another measurement from here to here. Let me put that right there. I wish it gave me the length of my... Oh, it does give me the altitude there, that little dotted line. I'm going to drop it right down here. I think that's where it's at. I'm not going to get too bent out of shape about it. Hopefully, Mr. Pettibone is okay with these rough estimations. I think most teachers understand that this is not... Technology here leaves something to be desired. All right, I'm going to take another measurement here. All right, there's my measurement. Now, unfortunately, I can't use the altitude in this case, right? Because the altitude would be a hypotenuse. I actually need to like bring it down, and it doesn't give me a length. So I'm just trying to do my best and not to mess up the distance of the line too badly when I do that. I like that way better than me using a tool you don't have, because you're gonna have to do this eventually on your own. Um, I almost forget which one I did. Did I measure that one correctly? I'm gonna try that one. Hopefully that's not right on top of the other one. No, it's no. I think that's just beyond. I'm trying not to mess this up. And then last one, last measurement. Putting that on B, measuring over. Oh, right to the big line. Is that it? Yeah, that's it. These lines are gonna be really close together, right? Because it's getting really steep right there. See why I can't use the altitude? See what happens? It's like in between the other two. This is really a hypotenuse of a right triangle. And it's going to be like right there. You know what would be an even cooler way to do this, now that I think about it? Mr. Pettibone probably already knows this and he's already showed it to you, and I'm just learning this for the first time. What if we used a circle to do a measurement? Oh, well, now we have to figure out how to create a perfect square circle. Well, I think I know how to do that. Let me select this circle and get rid of it. Drawing. I'm going to select a circle drawing. I'm going to hold down the control button this time, and that should create. No. Hold on the shift button. No, that's gonna. I don't want that. Oh, that's because I selected. I chose drawing, so that's why that didn't work. Let me go back to shapes. Choose ellipse. I'm gonna hold down the control button. Usually this works. Nope. Hold down the Alt button. Nope. So I want to hold down a button that will keep it to be a perfect circle all the time. What if I do the shift button? Will that keep it that keeps it a perfect circle? Holding down shift in Cami keeps us a perfect circle. Now, see, this is getting my background in geometry here. Getting rid of that. Getting rid of that. Another way, I'm glad I'm discovering this, to take a measurement of distance is to use a circle. Now we ain't got to mess around with that. Oh, I forgot to hold down shift. Let me try that again. Holding down shift this time. Let me take a measurement from here to this dark line over there, all right? Notice how that's I chose distance from B to there. Now, actually, I'm not crazy about not crazy about how I did that, but I think that's a diameter. Pretty sure, I hope it's a diameter. And so now, hey, I'm not too far off. I'm not too far off from the marking that I made right there. Just kind of eyeball it. So anyway, just to show it to you one more time, I'm going to take a distance between B and then this little intersection of the line right there, that contour line. Holding down the shift key, showing you how to do this. Do the circle. I'm going to stop it right there. And then I can choose select. And I can pull this. Oh, gosh, I didn't want that. I need to pull the circle down without malforming it. Putting one side on B. And my marking's a little off on that one. That's okay. But that's kind of how you can do that with a circle. Now you don't have to worry about the angles and the hypotenuse and all that kind of crazy stuff. Anyway, I think this is close enough. If Mr. Pettibone wants it done a different way, he'll tell you. All right, 540. No, I start 550 to 540. So this one here is going to be 540. All right, that's between here and there. And then my next one is 530. Right here, 530. Probably should use my pen for this. This make more sense. My next contour line is going to stay 530, right? What's the one that wraps around and goes right there? The water is somewhere in here somewhere. The Woodland Brook. And then I got to go up real high to 540. Remember, it gets real steep there. Notice how these lines get real close together? That's why it indicates you have a lot more change in altitude. All right, this is a lot more steep. And then it gets real flat, 550 to 550. And then so So if I was going to draw this line in, it would look something like that. All right. That is how to get that one done. Oh, let's see. Do I have time for how many more of these do I want to do? And I know this is a practice assignment, which is why I wanted to hit this up. And it's a huge assignment. It's got lots of stuff to it. There's lots to do in here, which is why I wanted to try to do a few of these. I figure I'm gonna leave these for you, since I've already kind of done a couple of those. Right? I'll leave this one for you to do. I don't think there's anything special going on there. Probably gonna do a topographic profile between C and D, is my guess. Yep. C starts at what? Well, you got to figure out what C starts at. Well, well, the contour interval is 100 feet. I'm going from 1,000 to 500 here. So that line's 900, 800, 700, 600, 500. It looks like I'm going from 500 to 1,000 over here. So this has got to be 600 for what it's worth. This is 600 feet. And where's D? D is going to be 600, 700. So your contour map is going to start at C at 600. It's going to go to 700. You're going down. You're staying the same. Remember, there's that creek going in between. That's the low point. And then you're going up to 600, up to 700. You'll have to take the measurement of those distances. Maybe use that circle or the line tool, whichever one you like, and do that interval. I think you can handle that from here. Let me see if there's anything crazy going on in this one. It's going to be another contour line of Lake Ontario. Lake Ontario is the lake that we have north of us here in Rochester, New York. Let's see, we're going to start at, do I see a contour line? Because they're all labeled, they don't have a contour line key, so I'm guessing this is 0, right? The shoreline is going to be 0. That's our sea level for this particular problem. And these are, of course, going down, right? Because the lake levels are measured in how many feet from the surface down. So 100 feet, 200 feet, 300 feet deep, 400 feet deep. Did you even know that Lake Ontario got to 700 feet deep? I didn't know that. All right, so this one, we're going to start at A at 0, down 100, down 200, down 300, down to 400, staying at 400, going back up to 300, back up to 200, back up 100. The only trick here is to take those measurements with the circle tool or the line tool and then plot those on plot those. Oh, it's going to plot down, right? So this is going to have this kind of U-y shape to it. Okay. Let me see. I'm just looking for things that are different from the first two examples I gave you. I'm trying to give you like the hints and tricks to do these. There's AB. Let's see, what's the question going to ask us? Oh, which cross-section represents an accurate profile of the landscape between C and D? All right, let me examine what's going on with C and D. I'm starting at 300 foot at C. I'm ending at 290 feet. I'm ending at 290 feet at D. How did I know that? I quick looked at the contour interval was 10. I saw that this line was 300. I see that this is a hill, which means I'm going down the hill, down the gradient, which means the next one's going to be 290. So starting at 300, ending at 290. Let's see, they all start at 300. These starting place points look good. Those starting points look good. That's wrong. That's wrong. That's not right. That's not right. So it's one of these two. Let's figure out. We figured out through our starting points. Let's see what's happening. So I start at 300. I'm going down to 290. I'm going down to 280, to 270, to 260. And this, right, is a depression mark. So this means I'm going down 260 to 250, staying at 250, coming back up to 260. So I need to say something. I bottom out at 250. So I need something that bottoms out at about 250. Oh, they both do that. They both. Oh, wait. This one comes back up a little bit. Right? We said this one was wrong because the starting points were wrong. This one has the correct starting points, but there's this little hump in the middle, and we don't see a hump in the middle of ours. This is just a depression going down. So this is probably our choice here. Choice 1. Let's see, a topographic map and an incorrectly constructed profile. Okay, from A to H. Got it. What mistake was made during the construction of this profile? Well, it started at 160. I like that. Starts at 160. I like that. It ends. That's 160, 170, 180. Should end at 180. I like the starting points. The general shape should be it's going uphill from A to B. Yep, that's what's happening. And then it goes from C to D, should be going downhill. That's what's happening. D is at 150. I like that. 150. E is, let's see, probably going down by tens here because I have 150 here and 100 there. So this should be 140, 130, 120. Is E at 120? Yes, it is. And then it bottoms out. Yep, it bottoms out and goes up to F. Is F at 120? 140, 130, 120. Yeah. Okay. Oh, okay. So I like the contour interval they're using. That looks fine. Do the distances look okay? Oh, the distances don't look right. The distances don't look right. I just noticed that now. Believe it or not. I just noticed that suddenly I was like, the interval looks fine. But I was like, A and B are kind of close together here. I was like, A and B are kind of far away here. B and C is a little bit further than A and B, and that's B and C looks a little shorter in distance between A and B. And then I'm noticing what's a nice long distance between contour points? E and F have the longest distance between contour points. But look at this, E and F are really close together. So that's what's wrong here. They did not properly measure these tick marks, and they did not apply it to their graph. So let me see which choice. Plotting points A through H the same distance apart horizontally. Yeah, I think that's what they did. I think they plotted A through H the same distance horizontally. Did they draw a curved line instead of a straight line? No. That's fine. Increasing the elevation from point F to point H? No, that's fine. So that's 2. They plotted it. They kind of did this even spacing thing when they should have measured these distances using a ruler or a circle tool or a line and made those more to scale. All right. Ooh, figure 6 is different. Good. Got something different going on here. Base your answer to the question on the map, which shows elevations in feet at various points. The southern part of the map has contour lines representing elevations at 20-foot intervals. Line A, B, C, A, B, and C, D are reference points in the map. Okay, there's A, B, there's C, D. What's the question? The question is on the grid. Construct a topographic map. Topographic profile along line AB by plotting the elevation of each contour line that crosses AB. Connect the plots with the line. Alrighty then. Let's see if we can do this. What I'm kind of need to do is I need to connect my contour line. So notice this is at 900, this is at 800. How many contour lines do I go? 1, 2, 3, 4, 5. That means I must be going by 20s. I must be counting by 20s to go 5 contour lines gets me up 100 feet or meters. What is this in? It's in feet. Contour intervals 20 feet. Oh, I could have just looked for the key and it would have told me it's 20 feet intervals. So what I would like to know is okay, 800, I would like to see the next contour interval. And I see there's a 780 there, a 780 there, a 780 there, a 780 there. That's nice. Let me try to draw a contour line that goes through all these. All right. Might start here and go through this line. And 780 is going to be just shy of 782. And it has to go through this point here. And then it's going to go navigate between those 2 points there. And do something like that. Alright, that's not the most beautiful contour line I ever saw, but it'll get the job done. The next contour line I would like to know is the 760s. So let me circle that. There's a 760. There's a 760. Any more 760s? It'd make my life easier if there was some more 760s in here. Ooh, there's one. All the way at the top. So let me kind of imagine where this is. 760 is going to be between 720 and 765. So let me draw that in there. That's going to be between here. Connect the dots there. 760 is going to be a little bit taller than 758, so I have to go around the 758. Can't touch that. Whoops. Oh, I did a little work. That was goofy. I goofed that one up. And then like that. All right. So everything above this should be higher. Right. I know if I goofed up, everything below this line should be below 760. Right. And then everything between here and there should be above 760. And I think all that works. And then 740, I like that. 740 is my next contour line. And I'm going to be above this, above 735, and below that. So if I was drawing another line, my line has to go through the 7. I'm going to go above 735, but below 748, and then I have to circle back. I can't cross this 720 is higher. I got to go back. So something like that is what I've got going on. I'm going to do a profile of C and D. So you're going to use those lines you drew in to create these contours, and you're going to measure this distance and then measure that distance. Oh, that's going to be a pretty easy one. Should I just do this one since it's so easy? I'm going to start at 800, right? There's the 800. There's 760. Let's see. 800, 880. Oh no, 800, 780, 760. Okay. Let me try this. I start at 800, I go to 760. Let me plot that. I start at 800. Wait, that can't be right. Where's the question? On the grid of AB. Oh, of AB? I did all that for nothing. I did all that for nothing. I thought for sure they're going to ask us about CD. Okay, never mind. We're going to do AB, and AB is a lot more straightforward. I start at 900. I end at 900. Let me see. I must be going down, right? This is a hill. So there's 800. So it's going down by 20, right? So this is 880. 880. And this is 860, which means that's 840. And it looks like that's going to be my low point in life, or in this. What was I doing? Go, come back, little dots. I was pressing. I have this little magic board here where I can write on it with a little magic pen, and I was pressing a button, and all my work went away. Oh well. Let me redo it. 880, 860, 840. Right, I'm going down by 20. Contour interval of 20 feet. This is my low point in this map, which means that I must be coming back up. So this is 840 is my guess, because I don't see a line in between it. And I'm coming back up. Let me just try go from here. 900 be 880, and yeah, 860. Everything works out nicely. So, here's where I'm going to start at 900, end at 900. All right, there we go. Start at 900, end at 900. I'm going to use the circle tool pretty exclusively now that I figured out that little method. All right, I'm holding down the shift key, starting at A. I'm going to measure my perfect circle to 880. There's my circle. And I goofed that up. There we go. I need to select. Select. Hello, little circle. I would like you to. Oh no! In my little buddy circle, he won't go to another page. He's stuck on this page. Okay, let me see if I can. Let me see what I can do here. Let me select. I can Control C. Can I Control V over here? Nope. I still get that. Okay. Well, that stinks. That stinks. I'm gonna have to eyeball it then. I'm just gonna have to eyeball it. We're limited by the technology. I'm not gonna break out the ruler again. You know the technique. I'm looking at something about, I don't know, what do you want to call it? A half inch for me? All right, I'm gonna do a half inch here. I'm gonna try to do a little half inch. And then I'm gonna go a little bit less than a half inch, third of an inch. And then I'm gonna go even less, like a quarter of an inch. And then I get like a whole inch. A whole inch. And then I got like a little half inch. And then hopefully, oh, did I goof it up? I called this a whole inch. I called that a half inch. Now I got 2/4 inches. I suppose it's not too bad. It's not too bad. It's not the best. I don't love it. I don't love what I just did, but I'm gonna live with it. All right, I go down. I go down to 840, and then I come back up. All right, I go down by 20. I go down by 20. Right, I'm just measuring this up here, kind of visualizing that. I go down by 20. It probably dips somewhere in there. There. Now I'm going up by 20. I'm going up by 20. And so my line's going to look something. I should be going through my dots if I'm doing it right. I'm just not that good at drawing. And that's that. All right. Okay. I think I am going to end this video here. We're about halfway through this practice. I think that gives you enough to get started. And hopefully that removes some of the intimidation factor of a big long assignment like this. And we've done about half of it. I know I skipped a few. That's what it is. I'm just looking if there's anything in here that looks to me like, whoa, that's really intimidating or hard. I really need to talk about this one. No, this is very different. It's a good fish, good creek for fishing in. Let's look at this. All right, this one's different, so let me talk about it. Which graph best represents the profile from B to C? Oh, that's from this question here. Well, we'll take a look at it. It looks like I go start at 1500. I'm dropping down to 1000. 1500. So I start at a high point. I kind of stay flat. I go down to 1000, and I come back up. So I start at a high point. I come back. I go down to 1000, and then I come back up. And gets kind of flat there. Yeah, that could be it. Number one could be it. It starts right. It ends right. This one starts right and ends right. But see, it's missing this piece here. I don't like that. It just dropped off things. And then starts right, ends right. Okay, so we really need to think about this carefully because these are all start right, end right. But do they do the right thing in between? So what I should have is it should be really steep on the C side. It should be flat and then really steep and then kind of flat and then okay-ish steep. So whatever we're looking for something that's really steep on the right and not as steep on the left. This is hitting it for me, and also this. These two are both hitting it for me. This is the one I like the most because it's got that wide flat spot at the bottom. Right? We got that wide flat spot at the bottom. And then I have all my stuff. Yep. For me, the 4 is what's hitting it. 4 is what's hitting it for me. All right. This one, it's steep on the right. It's not slope, but it doesn't have that wide bottom that this has, right? And then for this one, they didn't even bother completing it, right? They just kind of dropped off. Okay. Diagram is a three-dimensional model of landscape region. All right, three-dimensional model. Got it. 100 feet, 200 feet, river. Got it. Okay. Which map best represents the view of the topography of the region? Well, I like this, except for, I guess I don't know. I guess this is all right. I don't see anything I hate here. This one here is missing the river. This one's out. This one here has got this hill cross section on the wrong side. I don't like that hill is over there. And then, of course, this hill is also sectioned on the wrong side. So this one's out. This one's okay-ish. Got the river. Not enough elevation on the hill. Not enough elevation on the hill. There's no contours here. There's contours there. So this is the one. This is the one. All right. That's how you think these through. I think I'll stop there. I don't think we need to go through the entire thing. If you have specific questions on specific ones, you're stumped, shoot me a line. I'm going to put this video in the assignment. And if you're stumped on a particular one, maybe I can make a video on a particular one. All right. I'm Mr. Salt. Usually I close these with a say, I'll see you in class. But in this case, I'll just see you in the halls, all right? Have a good day.